Welcome to Cisco Hypershield, the most consequential new security product that Cisco has launched in 40 years. It is not the next generation of anything, but the first generation of something new. Cisco Hypershield reimagines security with a unique architecture built specifically for AI workloads. So here we have two important hot things, AI and security. Therefore, if we think of these two, we can predict that AI can help threat actors become more effective. They will become harder to discover and mitigate. And actually, over the past years, attackers need to win only once, while defenders need to win every time. So, if AI was added to the mix for the threat actor's advantage, it could make things worse. But here is the good news. AI can work for defenders' advantage also, and at a scale better than that of the attackers. And the reason behind this is data centers evolution. So, we will have a web of data centers that is going to operate as one, in a much larger scale than what we have today. These will give us, the defenders, for the first time, the data advantage, and it is a data game. The one who has the most data wins. So, data centers are changing and will be changing in two ways. First, we have the infrastructure, where the traditional CPUs use sequential processing, but now we have GPUs or graphics processing units that allow for largely parallel processing that will be very useful for AI workloads. And we now also have DPUs, or data processing units, also known as infrastructure processing units or smart interface network cards. Those DPUs integrate a general purpose CPU with the NIC, freeing the main CPU of complex networking duties and allowing for performing tasks such as encryption, decryption, firewalling, and protocols processing with a very lower latency. So this change in infrastructure will help us to win the data game against the attackers. And the second change is in applications. So instead of the three-tier architecture, we have now moved to the microservices architecture, where there are too many of those microservices separated into different clusters that need some type of communication filtering to be set in between. So these changes in infrastructure and applications require a new way of handling security. It has to fundamentally be reimagined. And we have three challenges. The huge gap in time between exploiting a disclosed vulnerability, which can range from a few days to just a few hours or minutes, and implementing a patch for this vulnerability can be several weeks, especially given the challenge of patching numerous devices, some of which, particularly IoT devices, may not be designed for efficient patching in the first place. The difficulty of network segmentation to prevent an attack from spreading through lateral movement, and this is because of the microservices architecture, where there can be billions or even trillions of users, applications, and IoT devices communicating with each other. Upgrading the infrastructure can be extremely challenging due to the possibility of very tight change control windows. And I will talk about these challenges in more detail in the next lectures. These challenges or problems can be solved, but they were not easily resolved due to the absence of core essential building blocks in the past. With the availability of these core components now, we can completely reimagine the cybersecurity solution and address these challenges. And these building blocks are Extended Berkeley Packet Filter, which is an agent that will give you complete visibility inside your operating system by observing every single I/O operation and process to create a fingerprint for it. And then the security infrastructure will check for any anomalies outside these fingerprints that require further investigation. Accelerated hardware, and this is DPUs or data processing units that I have talked about shortly before, that speed up repetitive network tasks and any kind of I/O operation, enabling high-speed processing of network traffic and advanced security processing at a large scale. Running a hardware-accelerated version of our network enforcement point on these DPUs allows enforcement to be placed on networking hardware close to the workloads. Artificial intelligence, with the ideas of preventing exploits even before a patch is applied, automating and accelerating the testing and development of patching. And with AI, we could have multiple distributed, hyper-coordinated enforcement points. Enforcing rules centrally is not efficient due to the need to shuttle traffic to and from the enforcement point, which creates networking and security design challenges. The solution to this problem is to distribute the enforcement point near the workload instead of having a firewall at the perimeter. However, the security policy remains centralized. When a new policy is created or an old one is updated, it is compiled and placed intelligently on the relevant enforcement points. Does that remind you of SDN concepts? And here, this centralized policy and management of enforcement points that we could have thousands or even millions of is done with artificial intelligence. Cisco is extending its partnership with NVIDIA to build very specific security models with AI. And I will talk about these building blocks in more details in the next lectures.